Being an extremely powerful telescope it is, the Nancy Grace Roman Space Telescope with a humongously wide field of view will generate unseen images of the universe. This will help astronomers understand some of our greatest mysteries, which is why expansion of the universe seems to be accelerating. In this video, we will learn about some of the observational strategies that have been planned with the telescope. As you can see from the title of the video, this is a continuing series on the Nancy Grace Roman Space Telescope, which will be launched in the near future. Or you may be watching this video after it has been launched already. Guys, I'm so excited about this telescope and its huge potential for various cosmic discoveries. So I've created this multi-part series on the Nancy Roman Grace Telescope. There are separate episodes about the telescope, dark energy, observational strategies, microlensing, exoplanets, etc. They're all placed in the video cards appearing above and also in the description of the video given below. In every video, I'll be doing a shout out to my subscribers. In today's video, my shout out is for Vister IQ, who has her own anime channel, and Arjun Kumar. Coming back to the video, over the course of time, as we observed the brightness and distances of supernovae, it provided the first evidence for the presence of dark energy. The Roman Space Telescope will extend these studies to greater distances to measure how dark energy's influence increased over time. As to why the universe seems to be expanding, the reasons could be the unexplained pressure that makes up 68% of the total content of the cosmos, the pressure called dark energy. This could be due to breakdown of Einstein's theory of relativity over large swaths of the universe. In the process, the mission will study galaxies across cosmic time, from the present back to when the universe was only 500 million years old, or about 4% of its current age. The telescope will use its powerful 2.4 meter mirror and the wide field instrument to do two things: map how matter is structured and distributed throughout the universe, measure how the universe has expanded over time. Observational strategies planned. Surveys of exploding stars called supernovae and galaxy clusters. The Roman Space Telescope will measure precise distances to galaxy clusters to map how they grew over time, mapping out distribution of galaxies across 3 dimensions. It will also measure distances to a lot of galaxies by measuring how their light becomes redder at greater distances. This phenomenon of shifting of light based on distance is called redshift. The farther off a galaxy is, the redder its light will appear when we see it. Mapping out 3D positions of galaxies will allow astronomers to measure how the distribution of galaxies have changed over time, providing another measure of how dark energy has affected the cosmos. Microlensing. Massive objects like galaxies can curve space-time in a way that bends light passing near them, thus creating a distorted, magnified view of galaxies far behind them. Using this magnifying glass effect called microlensing, the Roman Space Telescope will paint a broad picture of how matter is structured throughout the universe. Well, that's it in today's video. We will learn more about microlensing in the next episode.